Same thing happens in biology. We can determine whether life, in particular, the simplest possible reproducing cell, came about by accident, natural causes, or an unseen intelligent agent. And that's a crucial question to ask, because in order for the twin engines of evolution to get started, you need reproduction. The twin engines of evolution, which are variation and natural selection, do not get activated unless you have reproduction. So we now know what the probability that the simplest possible reproducing cell came about by accident or natural causes. But and I'll since you asked, I'll present that probability calculation, and I'm indebted to the writing of Stephen Meyer in the book Signature in the Cell, because he's the one who brought this to my attention. But you need something to compare it to. In statistics, which is part of the scientific induction method, you need an alpha level, where it's like it sets how low the probability has to be to reject the null hypothesis. So the most conservative alpha level in the industry is 10 to the negative 150th, not 0.05 like we do in
very conservative indeed.
It's very conservative. And as Will Dembski points out, it's based on the properties of the universe. And so, I mean, if you're interested in finding out more about where did Bill Dembski get that 10 to the negative 150th, that's well documented. That's something you can take a look at. But, okay, so taking that as the universal probability bound, I've written out here what I learned from Stephen Meyer in his writing about the probability that the simplest possible reproducing cell, maybe I can put it right here.
Sure.
So, in order, well, first of all, there's a couple of ways to analyze this problem. One is through amino acids, the other is through DNA. So this particular presentation is based on the amino acids needed for life, and it's just getting the amino acids together. It's not even forming them together. This is just to get the building materials. Now, proteins are formed by taking chains of amino acids and folding them into a state that's functional. And the average amino acid, the average protein is about 150 amino acids long. So I've got 1/2 to the 150th here. And that red 1/2 is the probability that a randomly selected amino acid from, let's say, this prebiotic soup happens to be a left-hand amino acid, because in life, all of the proteins have amino acids that are left-hand amino acids. So that'd be in a protein of average length, that probably would be 1/2 to the 150th. Now in green, that's the probability that the bonds between those 150 amino acids are peptide bonds. Bonds are either peptide or there's non-peptide bonds also. But Stephen Meyer uses an approximate probability of 1/2. You randomly select a bond, about half the time you'll get a peptide bond. So you need that 150 times. And then this last number, 1/10 to the 74th, is one that Douglas X published in the Journal of Molecular Biology back in August of 2004. You can check it. This is a respected scientific journal. And he looked at the prevalence of chains of amino acids that actually fold into functional proteins. It's very unusual for a randomly selected chain of amino acids to fold into a functional protein. And so he published that happens, the probability of that happening is 10 to the negative 74th, or 1/10 to the 74th. Now that's just for getting one string. Now, the simplest life that we know of has about 450 proteins, but scientists seem to agree that if you wanted to go bare bones, you'd probably be able to get the function of reproduction with 250 proteins. You'd get reproduction, and that's not even arranging them. That's like getting the building materials for a skyscraper, but no blueprints, just the building materials. So that becomes the probability of that. If you do the numbers, You have to get them. You have to use logs to get it all in terms of base 10, but it comes out to be about 10 to the negative 164. And then that's inside the red, the green, the blue is 10 to the negative 164.
And then you amplify that by.
But then when you raise it to 250, you get 10 to the negative 41,000.
Oh wow!
So I mean, you can check the math on that, but I've looked at that pretty closely. 10 to the negative 140, or 10 to the negative 41,000 is the probability of getting just the building materials, those 250 proteins.
So it's just an upper bound.
That all fold. And yeah, I mean, it is. It is an upper bound. The actual probability would be a lot less than that. And so, but since we're already at 10 to the negative 41,000, way less than 10 to the negative 150, which is universal probability bound, any reasonable person would have to conclude that we would reject the null hypothesis that the simplest possible reproducing cell came about by natural causes or accident. And there is overwhelmingly sufficient evidence that life came about as a result of intelligent design.